Hello everyone, to all of you who are watching this video right now. Our discussion will be about the chapter 4 of the research paper. This is the part where the researchers will put their presentation, analysis, and interpretation of data.
To start with, the J&T group will be presenting the presentation of data. But first, let us define what is presentation. Presentation is defined as the process of organizing data into logical, sequential, and meaningful categories and classifications to make them amenable to study and interpretation.
There are 3 ways to present your data. First is the textual presentation. These are statements with numerals or numbers that serve as supplements to tabular presentation. Second is the tabular presentation. This is a systematic arrangement of related ideas in which classes of numerical facts or data are given each row and their subclasses are given each column in order to present relationships of the sets of numerical facts or data in a definite, compact, and understandable form. There are 2 general rules regarding the independence of tables and text. Please remember these 2 rules. First, the table should be so constructed that it enables the reader to comprehend the data presented without referring to the text. And second, the text should be so written that it allows the reader to understand the argument presented without referring to the table. And for the last type of presentation of data is through graphical presentation. This involves chart or any graphics, may it be tables, columns, pie charts, in presenting the quantitative variations or changes of variables in pictorial or diagrammatic form.
The most common graphs that are used in your research are bar graph, linear graph, pie graphs, scatter plot, pictograms, and statistical maps. A bar graph is a graphical representation of information. It uses bars that extend to different heights to depict value. Bar graphs can be created with vertical bars, horizontal bars, grouped bars, or stacked bars. They are commonly used in business and financial analysis to display often complicated data. They can convey information quickly and effectively. In the financial industry, a volume chart is a commonly used vertical bar graph. Up next, we have the linear graph or line chart. A line graph is commonly used to display change over time as a series of data points connected by straight line segments on 2 axes. The line graph therefore helps to determine the relationship between 2 sets of values, with one data set always being dependent on the other set. The pie graph shows the component parts of a whole. The pie graph is a way of summarizing a set of nominal data or displaying the different values of a given variable. Example, percentage distribution. This is the scatter plot. Scatter plot uses dots to represent values for 2 different numeric variables. Scatter plots are used to observe relationships between variables. Pictogram or pictograph is a type of chart and graph that uses icons and images to represent data. It is often more difficult to visualize data precisely with a pictograph. This is why pictographs should be used carefully to avoid misrepresenting data, either accidentally or deliberately. You can use a pictogram whenever you want to make simple data more visually interesting, more memorable, or more engaging. Last but not the least, statistical maps. They're used to show the difference in values between different geographical regions in geospatial analysis. Modern statistical graphics include the use of satellite images and street-level views. It could be used to illustrate geographical variations of certain events, such as the differences in prevalence of events and benefit-risk decisions in different regions.
Now we, Team Naevis, will report the next part, the analysis. This is the part where we turn raw data into information. By the word analysis, according to Merriam-Webster Dictionary, it is a separation of a whole into its constituent parts. Meanwhile, according to Jose Calderon, author of a book titled Methods of Research and Thesis Writing, it is a process of breaking up the whole study into its constituent parts of categories according to the specific questions under the statement of the problem. For the purpose of research, data analysis is the process of inspecting, rearranging, modifying, and transforming data to extract useful information from it. It is also the process of understanding the collected data using statistical treatment or thematic analysis to come up with meaningful conclusion that satisfies your objectives.
The data analysis has two ways: the qualitative and quantitative analysis. Qualitative analysis, according to the Philippine Social Science Council, is not based on precise measurement and quantitative claims. It is a process of interpreting data collected during qualitative research, and its analysis depends on its type. Examples of qualitative analysis include social analysis, from the biggest to the smallest class, most important to the least important, and ranking of students according to brightness. Data analysis in qualitative research is defined as the process of systematically searching and arranging the interview transcripts, manuscript, observation notes, or other non-textual materials that the researcher accumulates to increase the understanding of the phenomenon. Analyzing qualitative data entails reading a large amount of transcripts, looking for similarities or differences, and subsequently categorizing and eventually finding and developing themes. Quantitative analysis, according to the Philippine Social Science Council, is employed on data that have been assigned some numerical values. It can range from the examination of simple frequencies to the description of events or phenomenon using descriptive statistics and to the investigation of correlation and causal hypothesis using various statistical tests. Quantitative analysis includes descriptive analysis and inferential statistics.
First of all, descriptive analysis allows us to characterize our data based on its properties. It is a type of data analysis that aids in describing, illustrating, or summarizing data points so that patterns that satisfy all of the data's requirements can emerge. It is one of the most important steps in the statistical data analysis process. It includes measures of frequency, central tendency, dispersion, and position. This analysis gives us a conclusion based on the distribution of data and help identify similarities between variables as well as find some outliers, thus aiding us in furthering our statistical analysis. Fundamentally, the measure of frequency is a measure of how many times something happens within a certain known period. This is usually used when we want to show how often a response is given. For example, you want to know how many females and males there are in one classroom. The prime purpose of measures of frequency is to make a count or percent. Next, the measure of central tendency is a typical value around which other figures congregate. It is the number used to represent the center or middle of a set of data values. The common types include the arithmetic, geometric, harmonic mean, the median, and the mode. The three means mentioned are the three classical Pythagorean means. The measures of dispersion helps us know how data is divided across a range. It is also called the measure of the variation of data values. There are two types, absolute and relative measures. To differentiate the two, absolute measurements of dispersion are dependent on the unit of the variable under study, whereas relative measures are unit independent. When comparing two or more distributions, relative measures of dispersion are used rather than absolute measurements of dispersion. Also, relative measures of dispersion are more difficult to compute and comprehend than absolute measures of dispersion. Lastly, descriptive analysis also involves identifying the position of a single value or its response in relation to other values in a sample or a population dataset. Measures like percentiles, quartiles, and deciles become very useful in this area of expertise.
Different from descriptive analysis, inferential statistics and research draws conclusions that cannot be derived from descriptive statistics. That is, to infer population opinion from the sample data through testing hypotheses and relating findings to the sample or populations. It is the process of using data analysis to infer properties of an underlying distribution of probability. In this analysis, it is impossible to measure every item in the population. Also, there is an uncertainty as to how well the sample results reflects the population. The two basic types of statistical inference are estimation and hypothesis testing.
Finally, after going through the most crucial parts of the analysis, we will now discuss about how to write one. In a communications program, Harvard Kennedy School formulated a few advices on writing an analysis. When you describe an existing situation, use that description for some analytic purpose. Respond to it, evaluate it according to some specific criteria, examine it for cause and effect linkages, contrast it to what happened elsewhere, to what might have been, or to what we have today. In formulating your analysis, it's important to determine the most suitable analytic design. The following are some of the most common designs. Number 1. Question and answer. A great way to start is to try answering your research questions. Number 2. Problem and solution. If your research circles on a current issue, start from there and try to know its root causes to finally arrive at a conclusion. Number 3. Hypothesis and proof. In this design, we try to find out about the truth of our hypothesis and the kind of relationship present between our variables. Number 4. Comparison and contrast, or determining the similarities and differences between the objects of our research. Number 5. Cause and effect. This is much like using the hypothesis design, since we're trying to see if there is a relationship between variables and what type of relationship it is. Lastly, number 6. Change over time. If our research centers on an object's life cycle, there is a lot we can observe in how its characteristics change over time. After finalizing which analytic design to utilize, here are a few more tips to keep in mind when making the analysis. First, develop only one main idea per paragraph. The first sentence of every paragraph should serve as a summary statement. The following sentences should then further expound on the main idea in a cohesive manner. Second, when making judgments or evaluations, mention your assumptions and criteria. It's important for the reader to grasp the overall concept as well as the specific variables that take part in it. For instance, if you use a Likert scale and it has a certain grade attached to it, explain how the results could translate to with the scale you established. Lastly, support key assertions with evidence. The data you collected should be the main driving point of your assertions, as they will also lay the groundwork for the rejection or acceptance of your hypothesis, as well as the conclusions you will eventually come up with.
The interpretation of Chapter 4 in the research content answers the question "so what?" in relation to the results of the study, or simply tells what do the results of the study mean. This part is perhaps the most critical aspect of the research report, and it demands perceptiveness and creativity from the researcher. More so, it includes conclusions that address all of the research questions, references to outcomes in Chapter 4, and all of the cover data bounded by the evidence collected. Therefore, this part of the research relates to the findings to a larger body of literature on the topic, including the conceptual or theoretical framework.
How do we interpret the results of our study? Not all research studies are scientifically sound or reliable. Thus, when interpreting research studies, it is important to consider each study's survey methodology, data quality, and validity. It is also important to determine if the study involved a control or baseline group. So when interpreting the results of the study, first, you need to tie up the results of the study in both theory and application. You can do this by pulling together the conceptual or theoretical framework, the review of literature, and the study's potential significance for application. Second, examine, summarize, interpret, and justify the results. Then, draw inferences. Inference is a process whereby a conclusion is drawn without complete certainty, but with some degree or probability relative to the evidence on which it is based. So, under here, you should consider the following. Conclude or summarize. This technique enables the reader to get the total picture of the findings in summarized form, and it helps orient the reader to the discussion that follows.
The next technique used in interpreting data is from the word itself, which is interpret. In this section, questions on the meaning of the findings, the methodology, the unexpected results, and the limitations and shortcomings of the study should be answered and interpreted. Third on the list is to integrate. Here, researchers attempt to put the pieces together. Often, the results of a study are disparate and do not seem to hang together. It must be made clear in the presentation of data interpretation that an effort has been made to synthesize or integrate the results and derive meaning and principles from them.
The fourth thing one can do to interpret data results is to theorize. When the study includes a number of related findings, it occasionally becomes possible to theorize. Theories should explain why things happen rather than just describe or predict. For you to be able to theorize, integrate your findings into a principle. The whole point of incorporating principles to your findings is to situate your own insights in the paper. Second is to integrate a theory into your findings, in order for you to propose explanations of the underlying causes or influences observed in the data gathered. And then, use these findings to formulate an original theory, if possible. Last on the list is to recommend or apply alternatives. The recommendations that you introduce in your research paper are essential to the plans you have to move your field of study forward. Recommendations are the added suggestions that you want people to follow and possibly apply as an alternative when performing future studies. These are all based on what you have found or what you might be interested in doing at some point in the future. As you write these recommendations, you will have to look at what you have gotten out of your paper while also thinking about any possible ideas you might have for later questions like what can be done, how feasible is the study, and what additional research is needed. Be certain when writing recommendations that are incorporated into your paper, as this can certainly be important to your study.
For the next part of data interpretation, the team next level will also discuss material that may help improve the part in deducing interpretation. The research can comprehend the abstract principle behind the findings through interpreting data. So the significance of the data interpretation contributes to the development of a strong study conclusion. As a result, it is important to make certain to utilize the appropriate technique to evaluate the data. So in deducing interpretation from statistical analysis, the following keywords or phrases may be useful. Number 1, table presents the. Number 2, table indicates the. Number 3, as reflected in the table, there is. Number 4, as observed, there is indeed. Number 5, delving deeper into the figures. Number 6, the illustrative graph above or below shows that. But before we get into those terms, let us first learn more about tables. Tables, as we all know, are often used in collecting and organizing raw data throughout an experiment, as well as displaying final data for inclusion in a paper or report. The depiction of data in a table is formally known as a tabular presentation. Tabular presentation of data allows to be structured for further analysis, enormous volumes of raw data to be sorted and reorganized in a nice style, and only the most significant or relevant data to be included. Table components include the following: title, table number, heading and subheadings, table body and spanner, dividers, and table notes. Let us now look at some example keywords or phrases for tabular presentation. Number 1, Table 1 presents the. Number 2, Table 1 indicates the. And number 3, as reflected in the table, there is a. It is very important to note that you should limit your tables to data that is relevant to the study's hypothesis. Include only the necessary number of tables in your work, or otherwise the reader may find it extraneous or confusing. To help user understand the data, include column or row totals or other numerical summaries. So now let us proceed to the graphical presentation. So graphs are used to illustrate data because it is simpler to see trends in data when it is presented graphically rather than statistically in table. Complicated data is typically easier to display and explain in graph style than in a data table. Line graphs, bar graphs, and scatter plots can be used to graph data. Line graphs are best type of graph to use when you are displaying a change in something over a continuous range. Bar graphs should be used when your data is not continuous but rather is divided into different categories. And lastly, scatter plots are used to evaluate the relationship between two different continuous variables. So these are the example keywords or phrases for graphical presentation. Number 4, as observed, there is indeed. Number 5, delving deeper into the figures. And number 6, the illustrative graph above or below shows that. So remember that to be consistent with your presentation when creating tables and graphs, maintain consistency in table title and heading forms. Make sure your table can stand alone without explanation. That is, you should be able to interpret the information in the figure without referring to anything else, such as the methods of section of the paper. Figures should also contain a meaningful caption that provides information about the independent and dependent variables.
We also have these phrases like in number 7, in explaining this result, it can be stated that. So this phrase can be used when you can already interpret a result. Next up we have is number 8, is significantly related to. So this phrase has the same thought with number 9, has significant relationship with. So you can both use these phrases when there's a situation when one is examining the association between any two sets of variables and if there is any significant relationship. So a statistically significant relationship is one that is large enough to be unlikely to have occurred in the sample if there is no relationship in the population. The issue of whether a result is unlikely to happen by chance is an important one in establishing cause and effect relationships from experimental data. We have number 10, registered positive correlation with. So we can use this phrase when there's a positive correlation between two variables. Since a positive correlation is a relationship between two variables that moves in the same direction. It exists when one variable decreases as the other variable decreases, or one variable increases while the other increases. Next is number 11, is revealed to influence. You can use this phrase when there are certain things or factors or conditions that lead to alteration, either positive or negative, in the ongoing or existing course of action. Next is number 12. We use this phrase when there is a factor or cause that makes something happen or leads directly to a decision.
Then we have number 13, is discovered to be a factor of. To be a factor of something means it helped produce a result. These factors are the variables in the study that we believe will influence the results. So we go back to our independent and dependent variables and see how they relate to each other. Number 14. In relation with the result of, it may be constructed that. So this indicates a cause and effect relationship. It is to connect a sentence that describes the result, followed by making an inference. Number 15. And in viewing in this sense, it can be stated that. This is simply to synthesize from different perspectives. You may provide a synthesis of arguments presented in the paper to show how these address the research problem and relates to the objectives of your study. Number 16. The result establishes the fact that. So we all know that research is a systematic investigation to establish facts and reach new conclusions. That is why when describing these results, you may state some statistical figures to ensure the credibility of your interpretation and of the research as a whole. Number 17. This finding suggests that. So in attempting to explain your findings, you may restate the purpose of your study. Then describe how it confirms or rejects the hypothesis underpinning your study, as well as how it differs or supports those of other studies and why. Number 18. With this result, the research developed an impression that it is more about understanding the context of your data. You may indicate opportunities or highlight the need for further research based on the result of your data.
Number 19. This finding also validates the findings of. Number 20. This improvement in could be understood in the context of. Number 21. These findings also accept the framework of the study. These are terms used when you are to compare the information that you have collected with previous bodies of data that you have done research on. For example, in this research paper conducted on a study on the level of investment awareness and involvement among full-time tertiary faculty of Xavier University main campus, it is shown that in their presentation of the graph, it hints to a possible relation between the results gathered through the research and the group's chosen framework of the study. Number 22, the interpretation marked as reveals that. Number 23, nevertheless, this finding could be attributed to the fact that. Number 24, probably this was also influenced. Number 25, in the rational sense, the juxtaposition of. And presented in the examples here, we can also use these phrases to explain our gathered data and the possible links and relationships it has with other factors that are presented in the research. Saavedra gives some guidelines in the presentation, analysis, and interpretation of data. Number 1, the chapter is organized and divided into several main components or topics, each of which is titled according to the sub-problem or hypothesis statement. Number 2, present only relevant data. Number 3, in reporting data, choose the medium that will present them effectively. Number 4, presenting tables that can be presented as well in a few sentences in the text must be avoided. Number 5, the textual presentation should supplement or expand the contents of tables and charts rather than simply duplicating what is inside of them. Number 6, only objective data embodied in tables are made the basis of discussion. Number 7, the analysis of the data should be objective and logical. Number 8, in analyzing and interpreting data, point out those that are consistent or inconsistent with the theory presented in the study's theoretical framework. Number 9, in reporting statistical tests of significance, include information concerning the value of the test, the degree of freedom, the probability level, and the direction of the effect. And number 10, The findings are compared and contrasted with that of other previous studies, and interpretations are made thereof. Thank you for listening to our presentation. I wish everyone a productive and fruitful Chapter 4.